Okay. Hi, everybody. So I'm Mike. Quick background on me. I spent a lot of time working on super production machine learning stuff at Google, running the ML systems that power the ads auction there. So every time you type a search into Google, there's a bunch of machine learning that happens in real time to determine like which ads to show. And so I was the product manager for that at Google for a number of years. And so you can think of that as being like super highly productionized machine learning, right? Powers Google's revenue. Then I joined Uber and helped start the machine learning team. It was kind of like the exact opposite. Joining as some early days in Uber, and it was kind of like, hey, we've got a bunch of data. We should do something with it. Like, how do we, like make Uber better with all of this data? Well, we're not going to have humans make these decisions with this data. We're not going to have humans do anything manually with this data. We're going to have some machines. We're going to have some automation use this data, and that's machine learning, right? And so started the machine learning team at Uber. We built the infrastructure that powers a lot of the machine learning at Uber. I'm going to talk a little bit about that today. And that platform is called Michelangelo. Through building that and going through this journey of helping a lot of teams go from 0 to 100 at Uber with machine learning, and through the work that we're doing at Tecton, we've really kind of like honed in on this pretty important mental framework that is key to just practical success out of getting value out of machine learning that you put into production. So like what does this talk about? It's about a lot of kind of like practical MLOps stuff of how you put of like data flows and how you do real-time ML, but more about the mental framework, the mental model that leads teams to be successful just practically. Like what patterns should they be thinking about? And so that's this concept of the ML Flywheel. Cool. So care about powering our products with machine learning. So there's a bunch of famous examples, like recommendations. At Uber, we had a ton of examples, right? Literally hundreds. We had tens of thousands of models in production doing stuff in real time. But hundreds of examples you can think of, right? ETAs, when's the car gonna get to me? That's powered by machine learning. Pricing, powered by machine learning. Surprisingly, there's a crazy amount of fraud at Uber. I didn't know about that before I joined, but the company was losing like $25 million a week to fraud or something crazy, something like super absurd. And so machine learning powers was kind of like the tool to solve all of these problems. And that's becoming the competitive frontier for applications. So, you're trying to build a good user experience. Well, what are you competing with your competitor on? Some user experience that's powered by machine learning in one way or another. Demand forecasting was a really critical thing for Uber to compete against Lyft. We just got better at predicting where are people going to be so we can send cars to them ahead of time so that there wouldn't be as much surge pricing so that Uber would be more competitive, right? It's just like a small example. But you can go on with examples. Fraud predictions, right? Is this transaction legit? Let me block this transaction. Across all kinds of companies. So just by show of hands, question in this group, who here is not like an ML vendor or associated with an ML company? Like a ML vendor company? Hand up. Okay. And then who, okay, thank you. And then, so a lot of people, and who is here as part of like their company is here kind of thing, as like a vendor here? I know you, but okay, great. Okay, that's good. So that helps me kind of like figure out how to tune what I'm talking about. So the challenge is like putting machine learning into your product, and how can you get a much better product, right? This is tough. What are the patterns? This is the kind of challenge that everybody's focused on. There's 4 main stages. We in such a project, and of course you can kind of structure this in many different ways. But let's think of ideation. That's like what problem am I solving? And how am I going to go about solving it? Let me design a solution. And development, let me build the first experiment, build the first few iterations of this thing, build a prototype. Productionization, let me get this thing into production. It's often a hard part. And get it up and running. Sometimes it's in real time, at scale. There's a lot of challenges. There's a lot of people talking about the challenges. And operation, which is like at a steady state. How do I keep this thing reliable? And how is my team on call for this system? And all of the kind of operational challenges on an ongoing basis. It should be no surprise to everybody what the like hard parts of this flow is, right? Productionization and operation, they're just tough. It's kind of like, these are the things that are still unsolved. Even though there's 50 companies here that work on different parts of these elements are just not like a solved turn a dial kind of thing for the vast majority of use cases. And so today we'll talk a little bit about like teams that are really successful with machine learning, what are they getting right and how are they solving this? And what kind of patterns do they think about to drive their philosophy towards this? But first, like who's doing this stuff? So there's kind of two kinds of ML teams that I want to talk about. And it's good for you to kind of think through if you fit into group one or into group two. So the first one I call ML product teams, or like a use case team. This is basically like, you're the team, you're on the fraud team, or you're on the pricing team, or something like that. You're trying to build some machine learning to, deliver some prediction to the product or to the end user application, right? So in your team, you probably have an engineer, you probably have a data scientist, maybe some like product, general product engineers kind of thing, and you interface with the infrastructure teams behind the scenes, right? So maybe there's a data team that provides you a bunch of awesome data sets for you to use, and they're kind of responsible for that, maybe some data infrastructure. And then there's a general infrastructure team. We'll just kind of like call them the infra people. But ultimately, you're delivering like predictions to a product, right? Maybe it's the recommendation that goes on the website. Maybe it's the price that goes in the website. Maybe it's just is this loan application approved or denied, whatever. But that's kind of like you run the ML, the end use case. In many companies, they have an ML platform team. So this is a separate team. And the ML platform team is tasked with enabling a bunch of product teams. So they're really about like, hey, we're going to have all these ML product teams. They're going to be doing a lot of the same stuff. There's like a lot of the same kind of engineering to connect to our data sets and to run training infrastructure and all of that kind of stuff. So let's just bring this all together into one team. We'll call it an ML platform team. They're going to be making like reusable components that we hope that all the product teams use and can get sped up by. So it's really about like how do we make the product teams successful. The platform teams, that's where it tends to be like engineering is consolidated there. It's like a lot more engineering people building like reusable engineering components. Think of like the serving system in your company or the training infrastructure or something like that. And they're responsible for interfacing with the data team and the infrastructure, so it's not so hard for the platform team, for the product teams to do that. And then on the product teams, in this kind of setup, in the product teams, then you have like that's kind of where your data scientists are, and you're kind of like the business experts. And so they're still delivering they're still like building the models on top of all the cool infrastructure that the platform team has built. So anyway, so two different types of teams, two different types of like organizational structures. It's a lot. It's like kind of complicated, right? There's like as a company, just think of from like a perspective of a company. I just want a recommendation on my website, and now I'm building like two different teams. I'm hiring like these ML engineering people who are like impossible to find, and there's data scientists who are probably like data analysts, and it's hard for me to figure out is a data scientist actually know machine learning or do they know SQL? It's like a really complicated thing for a company. It's a big investment for a company. And so what are they really trying to do? Well, it's all in service of that product, right? It's all like the whole point of it is just to get the recommendation on the website. And it's kind of like you can kind of abstract that all as just a decision API. It's It's kind of like all of the machine learning stuff, all of the internal details, all the people working on machine learning, they're just implementation details for the person who runs the website who's just like, tell me what the recommendation is. Or the business use case where the person runs the loans business and they're like, I don't care about all the models or whatever, just tell me, is this loan approved or not, right? And so I think a lot about machine learning teams as just implementing a decision API. And then all of the work that they do is implementing a decision library that their developers, the person building the website, the person building whatever other business logic can use. And so maybe it's not get decision, maybe it's get recommendation or get price or whatever the thing that's specific is. But the point is the end use case people do not care about the details of your ML application. They're just your customers, they're the business people, and they just want the decision. So why is this hard, right? Well, we can go and do like a machine learning tutorial and generate a prediction, but there's more requirements for things like this, right? It's not just generate one decision. It's one, generate an accurate decision. That part's obvious. But then it's generate decisions repeatedly, because you may be powering the loan applications where there could be many per day, or you could be powering credit card transaction approvals, which could be thousands per second, right? So that's a hard part. And then reliability, right? These need to be reliable. So how do we? So then that's a task for the ML teams. How do we make accurate decisions reliably and repeatedly? And so that's the kind of core framing of this problem. And intuitively, we know how to do this. It's not wow, this is some crazy thing that anybody in this room has not already solved. We do this today. Every time we make decisions, we make these decisions every day in our lives, right? And we have this feedback loop that we apply to it. Just think of I'm a basketball player and I'm trying to get good at basketball, taking shots, and I'm missing or I'm getting it in, and I'm learning from that, right? And so I kind of have this fundamental loop where I'm interacting with the real world, so I'm making my prediction, I'm making my decision, I'm doing something, and then I'm observing, what happened, right? I'm logging that, and as a basketball player, I'm just watching, did it go in or not? And I'm bringing that, integrating that with all the rest of the data I have, and then I'm learning again, updating my model, and then I'm taking maybe another shot now from a different part of the court or something like that, right? And so this is a fundamental loop that everybody does. Whatever you're not a basketball player, but you know how to drive. There's things you do every day where you're basically doing this again and again to become good at something. And so part of my claim in this talk is that the people who get really good at something are the people who get really good at this loop. And the people who are really good at machine learning, the ML applications that are really good, and the teams that become really successful at machine learning in practice, in production, are the people that build these loops and design these loops successfully and manage them actively. So, who's really good at, for example, who's the best at basketball? Michael Jordan, right? Well, that guy pays more attention to if he's way better at this loop than the next guy. And he goes after every game and he watches the replay so he can even observe more. And he's known for practicing more than everybody else and stuff like that. And so there's a little bit of a kind of metaphor of how do you get your ML application to kind of achieve that level of excellence. So all ML applications implement this feedback loop. So let's talk through this, right? Kind of can't see because this is supposed to be a little bit animated, but under product, you make a prediction in the product. You have a whole bunch of infrastructure behind the scenes to log what happened, to log did this person end up clicking on this ad, on this whatever item that I recommended? You create all these logs from what happened in production, and then you have, in this organized world, you have all this infrastructure to bring your data together and to model it and to generate clean data sets that your business has. That's what the data infrastructure team provides, right? They create these data sets, the modeled tables, and that goes in a warehouse or your data lake or whatever. And then there's a kind of a learning phase where you're turning that data into features, you're creating a training data set, you're building a model. And then from that, you have your models and your definitions of your features. From there, you got to use it. You're trying to affect the real world, the product again. So that's when you're serving a model. That's when you're serving features to help that model make that prediction. And depending on the use case, maybe there's a lot more complicated infrastructure online as well at prediction time, at inference time. It could be about like, how do we generate a bunch of candidates or power like a really scaled search or do 1,000 predictions a second, or there's a whole bunch of infrastructure that happens there. But the point is that every team that's really good at machine learning, they get really, really good at this loop. And it's not like some other random team does this thing and I don't know who it is and some other team does this. The teams that are really good at machine learning, they design this loop, they're very intentional about how they manage this loop, and they're very intentional about how they optimize it. Of course, they have people who focus on different parts of this loop, but they're very intentional about the architecture of the loop as a whole. And so we call it an ML flywheel because there's some compounding rewards from this kind of thing. There's compounding value. And you're really optimizing for how many times can I get through this loop, right? Every time you go through it, every time you retrain your model and things are accurate, and it works, then your application's getting better and better. So great ML applications require great machine learning flywheels. Okay, so what is it like when your machine learning flywheel is working, right? Well, in those cases, ML feels natural and easy. Things are just working. And so a lot of people, they never even been on a team like this because it's actually kind of rare to get all of this working nicely. But there's really clear ownership of who runs each part of the flywheel. I know that I need to add a feature, right? Well, I need some new data logged down here, and I know who to go to help to get that data logged, right? And then that data goes there, and then I can do some feature engineering on it. It's a lot more debuggable because you know who runs what. You can go and debug it pretty easily. It's a lot more transparent, and it leads to much higher reliability. A very important thing, though, is things just go faster. You want to make a small change, it's not a huge deal. It's like everybody knows their parts. Everything fits together nice and cleanly, and that allows models to stay accurate, and that allows things to be more reliable, and it allows you to make that accuracy in a repeatable way as well. So when this flywheel is not working, and frankly, this is the case for 90% of teams that are putting ML into production, it sucks, and it's kind of like the problem that's the problem that everybody, when they do those first intro slides and they're like, production doesn't work and operation is hard, that's because this is what's happening, right? There's a lot of, you don't know everybody that needs to be involved in all these different pieces. It's kind of like a little bit of unknown unknowns. You haven't mapped it all out. It's really slow to iterate because you don't even know who to talk to when you need some new data set for your ML model. You don't even know who to talk to when you need to do some infrastructure. And that not knowing who to talk to is a little bit of a symptom that's more present in a larger organization. But there's unclear owners, and it makes small changes feel like really big Herculean tasks. And a really good symptom of this that you can see if you're, maybe you're a consult for ML teams in different organizations, you go to them and you say, hey, your prototype, what version is it for your model, right? And they'll say, oh, it's I'm working on model version 22. Cool, what's running in production? Oh, well, version 1. Well, why are you working on model version 22 and version 1 is still in production? Why didn't you launch version 2? Weren't you going to get value out of that? And it's because there's bottlenecks throughout this process, and unlocking the whole process is really important. And figuring out what those dependencies are and mapping them out and designing your systems to reduce dependencies and mapping out all of the impact of any change, super important. And that's what leads to speed. That's what leads to reliability. So if you go to one of the top machine learning teams at Google or Facebook, they own the whole loop, and it's likely even the same person who is involved in every single stage of that loop. It's not possible for everybody to do that, but just really deep thorough understanding of the loop. So at Uber, we had like, things were totally broken before we built the ML infrastructure there. Frankly, to the point where like data scientists were just like, I'm not even gonna work on machine learning. They're like, there's so many things to do. Machine learning is kind of a dead end. Stuff's never gonna get to production anyway. So, because they just didn't know like who are the people that I work with at various stages to get into production. So, it's typical symptoms like high levels of silos, a variety of tools. The tools weren't integrated. Nobody knew where to get data sets from, all of that kind of stuff. And so part of what we did with Michelangelo, which is the ML platform we built at Uber, was just help people map these things out. Which infrastructure is where? How do you connect to it? How do we make all of the data sets be coherent and mutually understandable across these systems? So some of the challenges were that made data scientists not be able to have impact. Like they knew of a problem. We literally had millions of dollars a week that we were losing because we didn't solve this fraud problem. And the fraud team was like, yeah, maybe we should make dashboards about fraud to understand the problem better instead of like solve the problem. And it's just because solving the problem was hard because we just didn't have that flywheel connected and we couldn't make it happen. So how do we solve this problem? So imagine this, again, this slide's supposed to be animated, so imagine you don't see this big thing in front and you just see all the logos, right? It's kind of crazy to try to figure out how to solve this if you're just someone trying to build an ML system and you come to an ML ops conference and there's 50 vendors with like 500 different solutions and you're trying to duct tape all of these things together, right? And then they don't even fit together cleanly. So it's just really complicated. And what's needed is not just a solution that works for the ML platform team, not just a solution that works for like that ML use case team, but a solution that that is understandable and usable for also the people not directly working on the machine learning stuff, the people who are the stakeholders both at the front end of it, who are the infrastructure and the data teams, and on the other end, who are the product teams, right? So something that works for all stakeholders and allows them to build and orchestrate these ML and data tools into the tools that they have already. You don't need to buy a ton of special tools for this, but something that helps you connect all of these things into a coherent ML flywheels. That's the point. Like, can you get all of these things to work together really well? And so part of the claim and our approach at Uber, at Tecton, is to bring simple abstractions that allow people to define and manage these ML flywheels and manage the infrastructure and the artifacts that are powering them. So the artifacts are things like data sets, models, metrics, things that you generate as you're running the loop. And then the infrastructure are the elements that power them, your model serving system, for example, and your data platform. All of this needs to fit in really well with different people's workflows, right? So like engineering team, they needed to fit in really well with their CI/CD systems, and data scientists, it needs to plug really well into their data science notebook tool of choice, stuff like that. So that's kind of like the way that we need to solve this kind of problem. And so now I want to talk a little bit about that's a big problem. So rather than focusing on all of the problem, I want to talk about if you just think about the data slice of that problem, not the models flowing through this thing, not the metrics flowing through this thing, but we always hear data is the problem, it's the hardest part. And so one of the things that we focus on is data. And so what are the data sets that flow through this thing? Because to me, that kind of feels like more of the blood through the veins of the ML application. And other things are like metadata about what's happening. But this is the hardest part to me. And so there's a ton of different data sets that you can imagine, right? There's things that we're logging, observed features, predictions, ground truth, did the person click the thing that I recommended? And then the joined data sets afterwards. Let me get the joined data set of all of that, of all of those labels, and call it my label data set and make it available to everybody. And then let me extract features from that. Then we have a feature table. And I want to keep that up to date. And then I want to turn that into a training data set as well. So a bunch of different data sets throughout. And then when I'm in production, I'm doing inference. There's the features that I'm passing to the model so the model can make a prediction. That might be in real time. Maybe if it's a search use case and I'm doing ranking, it's not just features for one thing, but I'm ranking 1,000 things. So there's a data set of 1,000 different items with 1,000 different features each. So depending on your use case, there could be all kinds of different data sets that need to be flowing through the ML flywheel. And again, it's really important that all of these data sets, you could just kind of like piece it all together, and that's how you start typically. But when you really get going and you get these systems working reliably, accurately, and repeatedly, you want all of these data sets to just be compatible and flow into one another naturally. So you're not doing a bunch of manual stuff. So every time you're like, okay, now let me go manually log this thing and then manually update some features, et cetera. Let me load the features into production. You don't want to be doing that. That's not the connected flywheel. So, feature stores, they help on the top. And I'm going to talk a little bit about feature stores and feature platforms for a second. Feature stores, they help with like a couple of these data sets, right? At Tecton, we don't think about feature stores as much as we think about feature platforms. And so feature platforms we think of as the system that powers right now the data sets in the top half of the flywheel. So we've seen a lot of success. You're saying it's 5 minutes remaining, but it says 13 minutes remaining here. Sorry. So we've seen a lot of success with feature platforms helping with all of the different data sets that we talked about, right? Not just like storing a feature or storing a feature offline or storing a feature online, but computing those feature values, generating the training data set, generating the candidate set, all of those different things that we saw in production. And so I'll mention a little bit about like how a feature platform achieves that. It's got to be simple. It's got to have these simple abstractions. It's got to work for everybody, like we said, right? So what we do at Tecton, and there's not, tell you about Tecton, but you can figure out your own solution for this within your own company also. But at Tecton, we try to make it really easy for people to provide simple definitions. So here's just a Python file. You just write, there's 2 snippets you write, and it's a configuration for a data set. Here is the green part is just a SQL query. That could be Python code, that could be Spark SQL, or any Spark code, whatever. And then the purple part above is just some metadata that tells the system like, hey, what is this thing? This is a transformation, but like, how should it affect all of those different data sets throughout the ML flywheel? And then what Tecton does is it builds part of that ML flywheel for you. So it takes this very simple definition and it builds that productionized ML flywheel. So what we're seeing here is connecting to that data source, doing the transformation, whatever it is. This can be real-time stream transformation. This can be a batch, just a SQL query on your warehouse, whatever. Loading it into an online store to make predictions really quickly so you can serve in real time for inference, and then have a real-time API. And there's a bunch of other steps shown, but the point is managing all of the data flows in the ML application, at least the top half, that learn and decide stage, just from a simple like you add one simple configuration, right? And that handles all of the connections, the interlocking between all of the different infrastructure systems. So how do we bring that and apply that to the whole ML flywheel? So how do we bring that to the whole loop? And when we can do that, then we can make it really easy for people to build and manage their whole ML flywheel, right? We can give you a really simple way to define your model or your features, your data sets, and you can have all of the infrastructure throughout orchestrated and all of the data sets mutually compatible along the way. So a couple things we got to do. One, we got to close the loop. So we need the feature platforms, the stuff that we're using to manage the data on the top half of the loop. We need it to also support the bottom half of the loop. So we need to extend to also logging data from production into your data warehouse and to automatically model that data and organize it. And it needs to all be implemented on top of your data platforms because you have whatever, say you have Snowflake or Databricks or in some other data lake. you're not going to change your company's data lake to adopt a system. This system has to fit into your data infrastructure as is. That's kind of the challenge for ML people. Is they have to deal with like the data infrastructure that the team has, that the company has already. So that's number one. Number two is you need a unified data model throughout that flywheel. So you need data, every one of those pieces of infrastructure to have compatible data schemas that are automatically generated and maintained as things change all the way throughout the loop. So you want, okay, I'm creating a feature. Well, I want that to automatically update in my training data tables. I want it to update what's logged. I want it to update what's served in production. And we also want all of that stuff to stay up to date. We want the data to flow and propagate automatically throughout all of those data sets. So someone clicks on the product I recommended, and then that flows through to update features. It flows through to update training data sets. And then finally, as we mentioned, if you're doing ranking, you're doing search, different things, there's potentially more custom online infrastructure needed. Every use case is different. Well, you need, it's not a one-size-fits-all kind of thing. So if you're doing a real-time application, you're going to have a different infrastructure that's needed than if you're doing like some batch offline lead scoring or something like that. So you want the ML Flywheel to support your custom use case. So just to wrap up a little bit, at Tecton, what we're doing is building unified management of the data lifecycle for ML applications. So we're helping people build on the data layer support for the whole ML Flywheel, right? So that means simple declarative definition, get your infrastructure managed, and then get your data sets managed throughout that flywheel. Especially with like optimizing infrastructure for different use cases, right? If you're doing some online real-time thing, well then that's supported. That's important to have. You're giving me a time. I'm getting kicked out for time here, but I'm seeing 7 minutes. But I got 1 minute left. Okay, and so. So it's important to, so this is a tool, focus on making your ML flywheel efficient. Focus on helping you build and maintain that ML flywheel, implement it on your data stack, and it's important for that infrastructure to, and that tool to fit really well into your team's workflows for all those stakeholders, data scientists and engineers. Why is this, why does this matter? You have two different teams. The platform people, the only thing they care about is it easier for me to support my ML product teams? Makes it way easier for them. The ML product teams, they go faster. They make fewer mistakes. They have to build less code, less glue code, all of that kind of stuff, and there's way lower maintenance overall. But the more important thing is it gets you way closer to that mythical kind of like decision API that we talked about at the beginning. And this is relevant for all kinds of use cases, whether it's fraud detection, pricing, we have gaming use cases, security use cases, enterprise SaaS use cases. Doesn't matter what it is, you should be thinking about your ML flywheel. It doesn't have to be Tecton focused, but you should be thinking about and designing your ML flywheel for your application. Okay, so I hope convinced you that ML flywheels are super important. We're building an enterprise feature platform at Tecton that helps people build and maintain and manage those ML flywheels. We also maintain a project called Feast. It's an open source feature store. That's a really good way to get started with feature stores and manage a lot of the data flows in the top half of that flywheel. And I'll be around if you're interested, and I guess I don't have time for questions, but thank you very much.